Hello and welcome to Miss White's grade 11 college course. We are doing 8.5 effects of changing the conditions on investments and loans. Now, investments and loans are usually compound interest, so we're going to have to use our compound interest formulas. We do know future value, or A, is equal to P times P principal times 1 plus I to the n. I is the interest for the compounding period, and n is the number of compounding periods. So that's how we found future value. And to find present value, we just rearrange that formula. So we get P times A times 1 plus I to the negative n. Okay, and P and A are going to stand for the same things there. So example A, Zainab has $2,000 available to invest in an account that compounds annually. She will need the money in 6 to 8 years. So she has $2,000 available now. That tells us that that's going to be the P value, and she's compounding annually. That's important. In 6 to 8 years. So we're not really sure what N is because we're given a range of time. So A is graph the amount of her investment if she's earning 6% per annum. So I is going to be 6%, 0.06. And in part B, it says graph the amount of money if her investment is earning 12% per annum. So we're going to use I as 0.12. So here A is equal to P, which is 2,000, times 1 plus I, 1 plus 0.06, 1.06 to the n, because we're not sure what the number of compounding periods is. And the graph the amount of money if she's earning 12%. So A equals 2,000 again, times 1.12 to the n. So we're doubling the amount of interest she's earning, at least in terms of her percentage. That's what we know for sure. Okay, so we're going to graph that using Desmos. I'm just going to open Desmos here. And I actually graphed this earlier, so we're going to check that out. So 2,000 times 1.06 to the x. It's using x in this case because that's our independent variable. So instead of writing n, we just use x, same thing. So we can see that it's slowly rising up. If we zoom out a bit, you can see, oh yeah, that's definitely an exponential graph, right? So an exponential graph. So the shape is an exponential graph. And if I compare it to 1.12 to the x, so I'm doubling the interest rate. You can see that it starts at the same point. It starts at 0, 2,000. And then it shoots upwards a little bit faster, right? Or, well, actually a lot faster. I'm going to zoom out. Let's see. So you can see how much faster it's zooming out, or it's shooting upwards, right? So we're earning a lot more money in the long term using the 12%. But we were worried about 6 to 8 years. So we're going to look at the table of values here. I'm going to do 6. Well, 6 to 8, so let's do 6, 7, and 8. 6, 7, and 8. So this gives us some numbers. I already copied these down. You can see that at 6 years, the 6% interest is going to have $2,837.04 in her account. We're rounding to 2 decimal places because we're talking about money. And at 8 years, we've got $3,187.70. So she's earning a good amount of money. And for the 12%, let's look at table values for that. So do 6, 7, and 8 again so we can compare. Oops. And you can see that she's got these amounts of money. I wrote them down so we can analyze them on the other screen. So we're going to go back and compare those amounts. I'll leave there and go back to our question. So describe the shape of the graphs. They are exponential graphs. They're shooting upwards very quickly. Exponential. What happens when you change the total length of time the money is invested? Well, the longer you go, the more earning power you have. If we think about like how much we were earning at 6% or 6 years, the 6%, I wrote this down earlier, she had in her account $2,837.04. And after 8 years, Zainab had $3,187.70 in her account. And for 12%, after 6 years, she had $3,947. And you can see what a dramatic difference that is in 65 cents. Whereas in 8 years, she had $4,951.70. 93 cents. Okay, so here you can see that we haven't quite doubled the amount, but if we think about the interest, remember that interest is equal to the amount of interest earned is A minus P, the final amount minus the principal. So at 6%, after 6 years, it's going to be $2,837.04 minus $2,000, so $837.04 versus the 12%, where she has $1,947.65 in interest earned. Okay, so I'm just taking these numbers and I'm subtracting 2,000 because the original amount was 2,000. So you can see that this is more than doubling the amount of money, even though the interest rate is just doubled. So 6 times 2 is 12, but 837.04 times 2 point something, 2.3 or something like that, gives us 1947.65. So we're actually doing better than doubling our money by having a double interest rate. After 8 years, the interest here is going to be 1187.70, again, just subtracting 2,000. And for 12%, it's going to be $2,951.93. So you can see that I am almost tripling my money at 8 years with the 12%. So the lesson here is that even if you are doubling your interest rate, you're actually more than doubling the amount of interest that you're earning, which is pretty great. So let's look at an example B. Anne wants to have $5,000 in 4 years' time. So how much does she need to invest today at 4.5% per annum compounded quarterly, 4.5% per annum compounded semi-annually, and 4.5% per annum compounded annually? So in the last example, we're looking at what happens if I change the interest rate. In this one, we're looking at what happens if I change the frequency of the compounding period. So remember, quarterly happens 4 times a year, right? Semi-annually happens 2 times a year, and annually happens 1 time a year. We could have weekly, which is 52 times a year. We could have daily, 365 times a year, all of those things. Okay, so Anne wants to have $5,000 in 4 years' time. So she wants to have, that means she doesn't have it right now. So this is going to be our future value. This is our A. In 4 years' time, this is the number of years, but that doesn't tell us the number of compounding periods because it depends how often we compound, right? So how much does she need to invest today? That's going to be her present value, her P, at 4.5% per annum compounded quarterly. So again, we're going to use that formula. P equals A times 1 plus I to the negative N. And A is 5,000. Because we're compounding quarterly, we're going to divide the 4.5%, which is per year. We want to divide it by 4 because it adds up to 4.5%. So 0.045 divided by 4 to the And then the number of compounding periods, it's 4 years, and it's going to be 4 times a year. So it's 16 compounding periods. So negative 16. For this one, it's going to be 4 years times 2 compounding periods per year. So that's 8 compounding periods total, right? And for this one, 4 times 1, which is 4 times per year, or 4 times for the 4 years. So if I type this into my calculator, you can just type that all in. You're going to get $4,180.55. Okay. And if I think about the amount of interest that I earned, again, it's I equals A minus P. So it's going to be 5,000 minus 4180.55. And this is going to be equal to $819.45. So that's the amount of interest she earns if we compound quarterly. Compounding semi-annually using the same formula, always writing our formula out beforehand because that's good form. 5,000 times 1 plus 0.045 divided by 2, because we have 2 compounding periods per year, to the negative 8, because it's going to be 8 compounding periods. So this comes out to $4,184.69. So you can see that this amount is actually higher than this amount. So when I compound more frequently, I have to put less money in. So I'm going to earn more interest. So if you think about the interest here, interest is A minus P. So 5,000 minus $4,184.69, which gives us $815.31. So I actually earn less interest if I compound less frequently. More interest if I compound more frequently, less interest if I compound less frequently. So if I compound annually, which is even less frequently, you can guess that I'm going to have even more money in my account in order to get to 5,000, right? So let's try it. P equals A times 1 plus I to the negative n. Again, just writing our formula out and showing the substitution. 1.045, because I'm just dividing by 1. To the negative 4. I already found my compounding period here. And this amount ends up being $4,192.81. So even more money than before. So to get to $5,000, if you're compounding less frequently, you need to put in more money. Makes sense? Because you're earning less interest. So less frequent, less interest. Okay, so the 2 takeaways that I wanted you to get from this lesson. Number 1, if you're doubling your interest rate or if you're increasing your interest rate, you're going to do even better than doubling or whatever you put in. So the higher your interest rate, the better it is, and the longer you're in there, the even better, okay? And then the other takeaway is that if you compound more frequently, you're going to gain more interest for the same amount of time at the same interest rate. Okay, thanks and have a good day.